All right, here we go. Unit review. Hey guys, I'm making videos, okay? So just try not to be too loud. All right, here we go. So this first one, look, just factor, right? So you've got, we're going to 0. Now, we wouldn't have to factor if it was going to infinity. Then we just look at the powers and use the end behavior model. But in this case, we're going to factor and see if we can't get rid of something. Because if I do plug in a 0, which is usually should be your first instinct, you're actually going to get a 0 over 0. All right. So let's go ahead and just take a look at this and see that we can take out a 3x squared in the very top. Okay. I can take 2 x's, I can take 2 out of this guy, and I take a 3 out, so that leaves me with x to the third plus 4. Okay. Now this guy's unfactorable. Okay, so that's pretty much as low as we can go as far as factoring. Then we're going to do that the same thing here. You can't take out a common denominator or a common factor here except x squared, which is good. That's exactly what we needed for this thing to work. And so we're going to get 5x squared plus 6. Okay. All right, so when that happens then, these guys will cancel out, and we're going to go ahead and be able to plug in 0. Now we haven't plugged in 0, so technically, we don't have to write the limit if you do this, but this is really to the third power, and then 5 doesn't matter, right? You're going to end up with 12 on the top and 6 on the bottom. So if you just go ahead and reduce that, you're going to get 2. Okay, this is going to run out. So the answer is 2. All right, number 2, we're going to do the same thing. It looks like we're going, okay, so nothing cancels out here. I cannot get the numerator to actually be an x minus 3 for it to cancel. I could even switch the order around, okay, but if I do that, you'll notice that, oh, that's going to be a minus 4. That doesn't help at all either. So what I'm doing now is I'm looking for an answer of infinity or negative infinity because nothing canceled out. Okay, so it's going to be one of these two guys. It cannot be these guys. So what I'm going to do though is pick which one of these. And so here is where you use the 3.1 or the 2.9. Like where are we, which side are we on? Now if we're on the left hand side, what we want to do is choose 2.9. Okay, and all we're doing here is trying to figure out whether or not this is going to be a positive or negative, because I know the answer is infinity. Okay, so let's see here. This is a 4 minus 3 times, now this is almost 9, so 4 minus 9 is going to give us a negative number no matter what. And this right here is going to give us a negative small number. So a double negative actually means that it's positive. So therefore it's going to be positive infinity that's going to. All right? Okay, so now let f be a function that is continuous on the closed interval from 3 to 5. And between 3 and 5, f of 3 equals 9, and f of 2 equals, f of 5 equals 22. Which of the following is guaranteed by the intermediate value theorem? Now what I'm going to do is I'm going to sketch a little bit here. Okay. All right, from 3 to 5, because I got a lot of numbers thrown at me and I want to know, are they x coordinates or y coordinates? Now here's the interval from 3 to 5, and we said that this guy is at 9. At 3 it's 9, and at 5 he's 22, so he's up there somewhere. Okay. All right. Now what this does, it's a little kind of, it's just a little nice little graphic that you can make sense of these numbers. Now we don't know the function at all, but what are we guaranteed with? F of x equals 11 has at least one solution in the open interval of 3 to 5. So, okay, along the open interval from 3 to 5, are we guaranteed at least one solution that would be 11? The answer is yes. Okay, now let's see if there's other ones that are correct. But I'm guaranteed 11 because in between 9 and 22, 11 has to occur. Okay, the IVT means that if you've got a closed interval, you are allowed to take all the values in between to those A and B. Okay. F of 4 equals 13. Is that true? F of 4 equals 13. We're not guaranteed that. Not at all. So that can't be it. F of x has at least one 0 between 3 and 5. No, not at all, because this is from positive to positive. We're not guaranteed that it's a 0. All right, what about f attains a maximum value on the open interval 3 to 5? Well, it looks like we don't know. We can't guarantee that because 5 is the highest, but we're not allowed to actually go up to it. We don't actually know the maximum value here, okay? Guaranteed by the IVT. Now what could happen is this guy goes up and then does that, okay? So we're not guaranteed anything as far as maximum values go. In fact, that's the IVT doesn't even talk about maximum values. So that's a no-no. All right, so last one for this video. Where are we at? 5 minutes. So if f of x equals 3x squared plus 4x, okay, then as h goes to 0, okay, all right, these are great ones here. As h goes to 0, if I plugged in a 0, I'm going to be dividing by 0, so that's not going to work here. So what I've got to do is, we've done these before, and these are kind of these are the big ones, okay? These are kind of the long problems. Let's figure out, we know what f of x equals, and that's this guy right here, but what is f of x plus h? So f of x plus h looks like this. We're going to open the window, okay? We're going to open the window of this function, and we're going to replace the x with an x plus h. Now remember, the h is going to 0. So it's going to be a very, like the h is very, very, very small. You just want a little bit more than x to the left or a little bit to the right, okay? All right, h is going to 0. Okay, so that's what that equals, and we're going to go ahead and we're going to FOIL that out. So x plus h times x plus h actually equals x squared plus x plus h plus x plus, I'm just foiling here, okay, plus h squared. So I can combine these two guys so that that is 2xh in the middle there. And so now this is actually this piece right here. Okay, so let's just cross that out. Oh, whoa, no, my bad. 3 times this. Okay, there's a lot of beautiful algebra here. Plus 4x plus h. Okay, so this is f of x plus h. And now what we're going to do is we're going to go ahead and put the minus f of x. The f of x is exactly as we see there, minus f of x. So make sure you put parentheses around it because we're going to be subtracting both of those. All right. So what do we get? We get 3x squared plus 2xh plus h squared plus 4x plus 4h minus 3x squared minus 4x. Beautiful. All right. So this whole thing is what we have in the numerator right here. And what are we going to do with this? We're going to divide everything by h, and the limit is going to go to 0. Okay, now something really beautiful happens with these types of problems. So everything should really kind of cancel out, okay? So let's take a look, see what we have that's going to make it cancel. All right, let's see, we got this guy and this guy, they'll cancel. We got a 4x and a negative 4x, cancel. And then it looks like we've got this right here. We've got the limit as h goes to 0. We've got 2xh plus h squared plus 4h all over h. And look at the beautiful thing that happens. All three of these guys actually have an h in them, so we can actually factor this h out. He will actually get absorbed by each one of these. So what you're left with is 2x plus h plus 4. But we still haven't made h go to 0. So if h is going to 0, we know that this guy is just going to 0. So it looks like, for some reason, we get 2x plus 4, and it should be 6x. Did I miss something here? Oh yeah, I didn't do this. Right there. Okay. So you were probably yelling at the TV, your screen. Okay. So that is a 6h, because I didn't distribute the 3 there. Okay. You might have saw that, and that's annoying to watch. So this ends up being 6. But you know, good thing I caught it, though. All right, so our final answer is 6x plus 4, which is over right there. Okay.
All right.